Hello, my name is Joshua Hill, and this is going to be a demonstration on the stress analysis workbench, also known as static study. For this exercise, I chose an I-beam from the company taberextrusions.com. It is a aluminum 6061T6 aluminum I-beam with the measurements of 5 by 8 with a web thickness of 1/4 inch, a flange thickness of 410,000, and a radius of 300,000. I extruded this out into a 10-foot length. As you can see here. And what we're going to want to do is make a stress analysis on this. So what you've got to do is you've got to go up here to the compass and pick static study. In order for this to work properly, you need to have a material. You'll have to have a restraint of some type, which they call a boundary condition, a load, and then you can run the simulation. So like I had said before, the material that I chose was a 6061T6. The boundary conditions that I'm going to use is a clamp. And what we're going to do is we're going to put it on the opposite side. Clamp it down. Next, we're going to apply a load. We're going to use pressure. We're going to pick this surface right here and apply a pressure of 100,000 pounds psi. As you can see here, it applies these to let you know that that's where the pressure is coming from. We'll come here to the simulate and start the simulation. Now sometimes, depending on your PC, this may take a minute or two, but generally runs pretty quickly. Just waiting for the computer to do its computations. And here are our results. From here you can do a play animation, which will move it. Personally, I would change the speed. That looks good. And then from here you can see the different results that you would get. This right here that it's displaying now is a von Mises stress test. This is a deformation. This is a displacement. The factor of safety. Reaction force vector. As you can see, it shows you which way it's going to stress there. Compression and tension is the last one. Now the other things that we can do here is we'll stop the animation. We'll come back up here to our boundary conditions. And we'll add another clamp. So let's select opposite face from which we previously selected. Come on. Select OK. it all back in. This is where you have to rerun the simulation. Yet again, this sometimes takes a couple of minutes, but usually fairly good and accurate and quick. Here are our results. Let's play this animation again. So here you can see the middle of it's going to be pressed down. Here's the reaction force vector. The factor of safety. The von Mises stress. Displacement. And deformation. From here you can create a report. You come down here and you click on the report. Here you would put in all of your company information, address, URLs, phone numbers, fax, all the needed information. Once you select OK, it will bring up a Word document for you to then hand off to your either supervisor or the engineer at the plant that you're working at. Let's do one more change in this one. We're going to change the load. So over here we can see that we've got pressure here, but we're going to delete that. So let's take that one out and let's put a load of pressure, but we're going to come from the side using the same 100,000 pounds per square inch. And let's run the simulation again. This generally takes a minute because it's got a lot of calculations to make in a short amount of time. Our simulation is complete. Let's look at our results and play the animation. Now you can see that it bends from the middle but from the opposite side. You can choose any side that you want. Some of these sides, if you were to pick, let's say for instance this line right here, you would have to make a handle in order to get this to work properly. Here's the displacement. Von Mises stress. Factor of safety. Reaction force vector. And compression tension. If you haven't noticed already, it seems to have a lot stronger structure going from side to side than it does from top to bottom. But this will conclude our demonstration, and I hope you have a great day. Thank you.